Hello, and this is our part 2 integral of integrated perimeter of an ellipse equation. In the part 1 video, we derived the equation for the perimeter of an ellipse. In part 2, we will integrate this equation to arrive at the distance around an ellipse, or its perimeter. Here we have our ellipse, semi-major axis A and the semi-minor axis B. And we want to calculate the distance around this ellipse, the perimeter. In order to integrate this equation, we will have to make use of the binomial expansion. We will expand this equation and integrate each term separately. The resulting perimeter S will be in the terms of the eccentricity of the ellipse. The below equation is from part 1 video. Okay, this is the distance around the ellipse equation. This is the equation to calculate the distance around the ellipse or the perimeter. 4a times the integral from 0 to pi over 2 times the square root of 1 minus epsilon squared times sine squared theta d theta. Epsilon squared is the eccentricity of the ellipse. The binomial expansion has the following terms. As you can see, this 1 minus x raised to the power of n is expanded out to all of these terms. I'm only going to calculate out to the first 4 terms because I want you to see the pattern that results. In knowing this pattern, you can calculate out to as many terms as you wish. So I'm going to calculate our equation. I'm going to derive our equation out 4 terms. Okay, that's 1, 2, 3, 4. These other terms, you can still go out to these terms if you choose once you see this pattern. Okay. Let's continue. The binomial expansion is 1 minus x raised to the power of n. 1 minus x raised to the power of n, and we expand that out to these terms, and it continues out. I'm only going out 1, 2, 3, 4 terms, where x is equal to epsilon squared sine squared theta, and n is equal to 1/2. Now we're going to plug into our binomial expansion. Let's continue. So 1 minus, and we substitute what we had back for x. And everywhere you see in 1/2, we had an n, okay? And we substitute into our equation. Okay, let's continue. Now all we have to do is integrate each term. So, okay, S is equal to 4a times the integral of the first term, the second term, the third term, and the fourth term. And then the fifth term, the sixth term, the seventh term. Okay, and I'm only going out to the fourth term. Okay, and I'm going to multiply each term in this expansion by 4a. And I want to show you, let me go back a few slides here. As you can see, the perimeter equation is equal to 4a times this integral here. And in calculus, the sum of the integrals is equal to the integral of the sum. So therefore, I'm going to multiply each one of those terms by 4a. Okay, don't worry, this is not as confusing as it appears. It's quite simple once you notice the pattern. Let's continue. Okay, let's integrate the first term. The first term is quite simple. It's 4a times the integral of 1 d theta. And the integral of 1 is theta. And so that's 4a times theta from 0 to pi over 2. And so we have 4a times pi over 2 minus 0. And then 4 is 2 times 2, so we move pi out front, and we have 2 times pi times a times 2 over 2, which is 1. Okay. Now let's integrate the second term. The second term is by multiplied by 4a again, that's minus 1/2 times the integral of from 0 to pi over 2 times epsilon squared sine squared theta, d theta. Well, epsilon squared is a constant, so we can move it out outside the integral sign. So now all we have to integrate is sine squared theta. Well, we have a trigonometric identity where sine squared theta is equal to 1 minus cosine 2 theta divided by 2. So now we just plug into the equation and we get 1 minus cosine 2 theta divided by 2, and we take the 2 out because it's a constant, and 2 times 2 is 4. So now we have the integral from 0 to pi over 2 of 1 minus cosine 2 theta d theta. Okay. And now we can separate those and take the integral of each term. Okay. So we have e squared over 4 minus e squared over 4 times the integral from 0 to pi over 2 times 1 d theta plus e squared over 4 times the integral from 0 to pi over 2 times cosine 2 theta d theta. Okay. And the integral of 1 is just theta from 0 to pi over 2. Pi over 2 minus 0. Let's continue. Then here's our previous equation. So we multiply pi over 2 times e squared 2 over 4 gives us pi e squared over 8 plus e squared over 4 times the integral from 0 to pi over 2 times cosine 2 theta. Well, cosine 2 theta d theta, cosine 2 theta is a trigonometric substitution we're going to use. Now let's integrate the second above term by substitution. What we're going to do is we're going to let u equals 2 theta. And so if u equals 2 theta, then du equals 2 d theta, and d theta equals du over 2. And because we do u substitution, we have to change the limits, okay? So when theta equals 0, right there, u equals 2 times 0 equals 0. So that's the bottom limit right there. When theta equals pi over 2, u equals 2 times pi over 2 equals pi. And that's the upper limit. Okay. So from u substitution, we change our limits and our u substitution. Okay. So now we have e squared over 4, e squared over 4 times the integral from 0 to pi cosine u over 2 du. Okay. And then we move the 2 out front. That makes it e squared over 8 times, and the integral of cosine u du is sine u. Well, sine u from 0 to pi is sine pi minus sine 0. Well, sine of 0 is 0, and the sine of pi 180 degrees is 0 also. So 0 times this is 0. Okay? So this is getting easier by the minute. So here's our previous answer and our substitution, which is 0. So therefore, S2 is equal to 4a times minus pi e squared over 8 plus 0. Rearranging terms, 2 times 2 is 4, remember? So that's 2 pi times a times 2 over 8 e squared, okay? Rearranging more terms, we get 2 pi times a times minus e squared over 4. Now, we take 4, which is 1 over 4, which is 1/2 squared, and we put 1 over e. We move the terms around. We're rearranging terms to develop this pattern, okay? So far, we have the first term and the second term right there, like that. And then we see the pattern that's developing. We factor out 2 pi a, and we get 2 pi a times 1 minus e squared over 1 times the quantity 1 in the numerator, 2 in the denominator squared. Okay, let's continue. Let's integrate the third term. 1, 2, 3. Okay, let's integrate this term in blue. It gets a little difficult, so we got to keep up with these terms. So 1/2 minus 1 is minus 1/2 times 1/2 is 1/4. And 2 factorial is 2 times 1, 2 factorial. And so we bring that out, 2. So that makes it minus e to the 4th divided by 8. Okay? And the integral from 0 to pi over 2 of sine squared theta, because we took e squared and squared it. So that makes it e to the 4th. And then we can bring it outside the integral. Okay? And we squared the sine squared theta. Okay, that's squared, but we're not going to square it. We're going to leave it there like that. Remember our trig identity? Sine squared theta equals 1 minus cosine 2 theta over 2. Well, we're going to substitute that into there, okay? And we're going to square it, see? So sine squared theta squared is equal to 1 minus cosine 2 theta over 2 squared, okay? And we're going to square that, okay? And there it is, multiplied by itself twice. So then we take the square of it, and we get 1 minus 2 cosine 2 theta plus cosine squared 2 theta divided by 4. Let's continue. So our previous third term and our identity, and now we can substitute. Now we got a longer integral here, okay? We know from previous calculations that what? The integral of from 0 to pi over 2 of cosine 2 theta is equal to 0. That's 0 because we know what it was previously, okay? So there's no sense in doing that again. So also, if cosine squared theta is equal to cosine 2 theta plus 1 divided by 2, then the cosine squared 2 theta right here is equal to cosine 4 theta plus 1 divided by 2. Trigonometric identities, you got to remember, okay? So let's continue. So here's our previous equation. And what we did was we substituted, this is 0, and cosine squared 2 theta is equal to cosine 4 theta plus 1 divided by 2, okay? So now we have, here's our previous equation, and here's our new identity, and we substitute in there, right there, our new identity, and then we get common denominators, okay? And 2 times 1 is 2, plus 1 is 3. That's where the 3 comes from. And the 2 is the common denominator, okay? So we bring the 2 out and multiply 2 times 1 over 4, and 1 over 8. Okay. Now, in order to solve cosine 4 theta, d theta, we know we have to let u substitution. So therefore, we let u equals 4 d theta, and du equals 4 d theta. Therefore, d theta equals du over 4. And then we change limits. Okay, the lower limit is 0. When theta equals 0, u equals 4 times 0, which is 0. And the upper limit, when theta equals pi over 2, u equals 4 times pi over 2 divided by 4 times pi over 2 equals 2 pi. So now our new equation is all of this multiplied by these two integrals, because we took the integral of the sum, okay, which is the integral of 3 d theta and the integral of cosine 4 theta d theta, and we changed 4 theta to u. We did a u substitution, and we changed the limits from 0 to 2 pi. Okay, let's continue. Okay, and now all of this is multiplied by these two integrals. Okay, and so this integral 1/4 0 to 2 pi cosine u d theta, and the integral of cosine u is sine u. So sine u from 0 to 2 pi is equal to sine 2 pi minus sine 0, which is also equal to 0. That's why I did that one first. So cosine 4 theta d theta is equal to 0. So this whole integral is 0 here. Therefore, our new equation, S3 is equal to 4a times the whole quantity of minus e to the fourth over 8 times 1/4 times 1/2 times the integral from 0 to pi over 2, 3 d theta. Well, 3 is a constant, so the integral of that is just 3 theta from 0 to pi over 2. And so now we got 3 times pi over 2 minus 0, multiplied by all of this. And what we do is we get 2 times 2 is 4, so we get 2 times, bring pi out here, times a, 2 pi times a, times 2, which leaves us 3 times 2 over 2, which is 1. Let's continue. That leaves 3. And now we substitute our terms. We move them around. We have 3 over 64, because that's minus e fourth over 64 times 3, which that equals to 1 times 3 divided by 2 times 4 squared, and we put a 3 here to account for the 3 that's up there. And we just rearrange these terms. So far we have 2 pi a times 1 minus e squared over 1 times 1 over 2 squared plus S3. Well, S3 is this. We just calculated that. So our total perimeter is equal to 2 pi a times the quantity 1 minus e squared over 1 times 1/2 squared minus e squared over 4, e squared to the power of, e to the fourth divided by 3 times 1 times 3 divided by 2 times 4 squared. The pattern is coming in, but let's do one more. Let's continue. Let's integrate the fourth term. Here's the fourth term in blue. Okay. So we have 4a times the quantity in blue. Okay. We do the algebra here with the minus 1/2 and so forth, and we come up with minus 3/8. 3 factorial is 3 times 2 times 1, so that's 6, okay? So that leaves us 3 goes to 6 2 times 8 is 16, so that's minus e to the 6 divided by 16 times the integral from 0 to pi over 2 times sine squared theta d theta. What we did was we multiplied e squared and we took e squared and cubed it. So that came out to e to the 6. So that's a minus in the front of that. So that's minus e to the 6. Okay. And the 3 goes into 2, 6. 3 goes to 6 2 times. 2 times 8 is 16. That's where that comes from. So now we cube sine squared. Okay. Well, we remember our trigonometry sine squared, right? We're using the same terms over and over again, as you can see. Sine squared theta is equal to 1 minus cosine 2 theta divided by 2. So we haven't done anything new, okay? Now we have to cube this, Okay, last time we squared it. Now we're cubing it. Okay. Sine, the cube of sine squared theta is equal to 1 minus cosine 2 theta divided by 2 cubed. Okay, let's continue. So, okay, here's our fourth term. Now we have to cube the identity. Okay. So we're going to cube that. And what we do is we take 1 minus cosine 2 theta divided by 2 and square it and then multiply it by itself again. That cubes it. Okay. And then we take the square and then we multiply the square by the cubed. Okay. And this is algebra. That's why you have to be good in algebra to study calculus, because there's a lot of algebra. So, okay, we multiply 2 times 4 is 8. So that's 1 over 8 times 1 minus 2 times cosine 2 theta plus cosine squared 2 theta times 1 minus cosine 2 theta. Let's continue. So, okay, our final equation is, our previous equation is, for sine squared theta cubed, we have 1/8 times 1 minus 2 cosine 2 theta plus cosine squared 2 theta times 1 minus cosine 2 theta. And we multiply all of that out. And the red terms, as you can see, add, and the blue terms are subtracted. And so now we have 1 minus 3 times cosine 2 theta plus 3 times cosine squared 2 theta minus cosine cubed 2 theta. Okay, and now we can substitute this into our equation. And now you can see why I kept this in such order, correct order, because if you don't, you get confused. And so, plus I'm reading from a video, and that helps get confusion also. But if you keep it in order, you won't get confused because there's a lot of algebra here. So now we substitute in. And we substitute in, and here's our final equation. Let's continue. Here's our previous equation. We know from previous calculations that cosine 2 theta is equal to 0, right there. Then we have 1 plus 3 times cosine squared 2 theta minus cosine cubed 2 theta d theta, okay? Also, we have the identity cosine squared theta is equal to cosine 2 theta plus 1 divided by 2. Then cosine squared 2 theta is equal to the quantity cosine 4 pi, cosine 4 theta plus 1 divided by 2. Let's continue. Okay, here's our previous term. Okay. We know from previous calculations that the integral from 0 to pi over 2 of cosine cubed 2 theta, right there, is equal to 0. We also know that the integral from 0 to pi over 2 of cosine 4 theta is equal to 0, right there. So therefore, we have this total integral of integral from 0 to pi over 2 plus 1, which is right there, d theta, plus 3/2 of the integral from 0 to pi over 2 times cosine 4 theta, which is 0, plus 1, d theta, minus the integral of from 0 to pi over 2 of cosine cubed 2 theta d theta. Okay. Our result, after we cancel these out and make them 0, this is 0 and this is 0, we get the integral from 0 to pi over 2 of 1 d theta right there, plus the 3/2 times the integral of from 0 to pi over 2 of plus 1, which is right there, and the rest of these is 0. Okay. Okay. So let's continue. Our previous fourth example is here, as we had before on the previous slide. After integration, we have the integral of 1 from 0 to pi over 2 is theta from 0 to pi over 2, and the integral of 1 from 0 to pi over 2 is theta 0 pi over 2, which is theta times pi over 2, theta times from 0 to pi over 2, and 3/2 times theta from 0 to pi over 2. Okay, so we get all of this times pi over 2 minus 1 plus 3/2 times pi over 2 minus 0. So we have minus 6 cubed, minus e to the power of 6 divided by 128 theta from 0 to pi over 2 plus 3/2 times theta from 0 to pi over 2. And when we take the limits on, use the limits on this, we get pi over 2 minus 0 and 3/2 times pi over 2 minus 0. And after some algebra, we get 5 pi over 4, and we get 128 times 5 pi over 4. And rearranging some terms, you remember 4 is 2 times 2. So 2, bring pi out front, so 2 pi times a, and we have a 2 in here from the 4. We divide that into 128 to get 64, and we got 5 over 4, and here's our previous equation. So we have 4 times 64 is 256, so we have 5 over 256. And to make this look like the remainder, the previous equations, we have a 5 under the 6, e to the 6, and we in the numerator we have 1, 3, 5, and denominator we have 2, 4, 6, and we square that. Okay, so far we have with our previous calculations, and now we have S4, which is 2 pi a times e to the 6 power 6 minus e to the power 6 over 5 times 135 divided by 246 squared. Okay, let's continue. And now this is our fourth term. Into already derived terms, we get our parameter is equal to 2 pi a, the semi-major axis, times 1 minus e squared over 1 times 1/2 squared minus e to the 4th over 3, and look at the pattern. Look at eccentricity. E squared, e to the 4th, e to the 6th. Divided into the eccentricity is 1, 3, 5. Multiplied by those terms is 1 over 2 squared. 1 times 3 divided by 2 times 4 squared. 1 times 3 times 5 divided by 2 times 4 times 6 squared. Can you guess what the next term is? Let's continue. Okay, the eccentricity is equal to the square root of 1 minus quantity b squared over a squared. Okay, so from this pattern, we can add more terms because we can see what the pattern is now. We got 2 pi a times the first term, 1 minus eccentricity squared divided by 1 times 1 over 2 squared. Eccentricity over 4, eccentricity raised to the power of 4, power of 6, power of 8, power of 10. Okay. Then we have 1 over 2, 1 times 3 over 2 times 4, 1 times 3 times 5 over 2 times 4 times 6, 1 times 3 times 5 times 7 over 2 times 4 times 6 times 8, 1 times 3 times 5 times 7 times 9 over 2 times 4 times 6 times 8 times 10, all of them squared. Over the e, we have e squared, e to the 4th, e to the 6th, e to the 8th, e to the 10th. Beneath the e, we have 1, 3, 5, 7, 9. You get the picture? Okay. That's the pattern. Let's solve a problem. Okay, let's use our equation to solve the circumference of an ellipse. And let's say our semi-major axis is 5, our semi-minor axis is 4, and from that we calculate the eccentricity, which is 0.6. So okay, here's our ellipse perimeter is equal to the first term, second term. Well, we got 2 pi a times the first term, the second term, the third term, the fourth term, the fifth term. Okay. Okay. These are the 4 terms we went out to. Okay. So, and 2 pi is multiplied by all of that. Well, here's our ellipse perimeter, 28.63. Okay. All right. So, and a circle is really a special type of an ellipse. Okay. And I can show you that with the radius of the Earth. The radius of the Earth. I said units here because I don't know whether I'm putting miles or inches. Okay, so I just put units here. But let's say the semi-major axis of the Earth is 3,963 miles. That's the radius of the Earth in the x direction, and the radius of the Earth in the y direction is the same thing, 3,963 miles. Okay. Okay, we do that, then the eccentricity is 0 because it's a circle. And if the eccentricity is 0, then the rest of these terms are 0, and our 2 pi times a comes out to be 24,900 miles, 900.26 miles. So essentially, the circumference of the Earth is 25,000 miles. Okay, approximately. All right. So let's say we have the semi-major axis is equal to 10,424.1, and the semi-minor axis is equal to 9,579.42. And we open this up. Oh, that's wrong here. Let's do that again. 10,424.1. Oh boy, I really messed that up, didn't I? 10,424.1. Okay. And we got eccentricity 0.39433, 62,870.97 miles, 97 units. Okay. So you can calculate the eccentricity, the perimeter of any ellipse. Just plug in the semi-major axis and the semi-minor axis. Okay. Semi-major axis is 10, and the minor axis is 5. We get 48.6 units. If we less than 9, and if we get 10, 10, it's a circle. 2 pi times a, and a is 10. Okay. And as you can see, if you put 1 in here, what you get? 2 pi times a is 1, and you get 2 pi. That's the circumference for a circle with a radius of 1. Okay? Until next time. Thank you.